Let's look at the slope of graphs. Okay, so let's take a look at a graph real quick. Here is just, a normal XY graph. There's the X, there's the Y, like math class all over again, except this one's blue. If we take a look at this, we know that if we had some sort of line on this, right, that this line could be represented by the equation y equals mx plus b. And this is some function that exists. And if you haven't seen the function video, make sure you go watch that. If you know what I'm talking about, then you know what I'm talking about. But this is some function here, right? And this is a linear line where this is the y-intercept right here. And the rise over run portion of it is the slope, right? That's our rise over run. And we're really going to talk about this slope in this video here. That's our main focus. What is the slope of a graph? So we know slope, that rise over run, can be thought of as a delta y, the rise, the amount you're changing vertically, over the run, which is the x, a delta x. And if we think about what these deltas mean, these deltas, remember, mean final minus initial. So we could say this is like the final y position minus the initial y position over the final x position minus the initial x position. And in your math classes, they'll probably say something like this is y2 minus y1 over x2 minus x1, right? Where this point up here could be like x2 comma y2, because it happens later. And the point way back here, this would be point x1 comma y1, okay? Now, what we're really going to focus on with slopes in this video is what the slope actually will mean for a graph. So if I look at my units on this axis here for the y and the x-axis, let's say my units over here are dollars, okay? It's like money. And on the x-axis, it is something like, I don't know, pounds of butter, because you're buying pounds of butter for some reason, right? When we think about the slope, we're thinking about the rise over the run. We're thinking about the y quantity over the x quantity, which means that the units of this slope are the y quantities, dollars per pounds of butter. Okay? This is what the slope physically means here. And this meaning of the slope is extremely important for us. The reason why it's extremely important is when we start talking about velocity graphs and position graphs. Well, let's think of a position graph here. Okay? Let's just say that this on the y-axis here is a position, okay, which is given to us in meters. And on our x-axis is some amount of time, which is given to us in seconds. Well, what would the units of the slope be on this graph? Well, they would be meters per seconds, which, that right there, this is a speed or a velocity. But my graph is showing position. So understanding what your graph has on its units means that the slope could physically mean something else. The slope, whatever it is, that slope could have some meaning to it, how fast an object is moving. And as we're going to see later on, the idea of a slope being positive or negative means things as well, because remember, our velocities are vectors. Direction matters. So please remember, as we're starting to look at stuff, slopes are a huge thing when we're graphing things, and we're really looking at what our units are telling us, one over the other, the y-axis over the x-axis, to say, do we have a new quantity that has come into existence? And with that, slopes are finished. Take a look at those position graphs, and we'll see some more uses of the slopes later on. Adios.